All right, y'all. So 7.5 deals with analyzing quadratic functions. So we're going to be analyzing quadratic functions. And really the main thing we're going to look at today is what we call the vertex formula. So I'm going to draw a graph and explain what the vertex is and then give you the formula. So I'll be drawing a graph of a parabola. Oh, and I'll just mark out about 5 each direction. All right, so my parabola, I'm going to cross here at -1 on the x-axis, and then it'll cross over here at 3 on the x-axis. So we just want to draw a little curvy parabola going through them points. And y'all, this point right here is going to be over 1 and down 3. So this point will be 1, -3. So when we talk about the vertex, we're talking about the lowest point on that parabola, or if it's flipped over, we're talking about the highest point on it. So we're talking about this point right here. That is what we call the vertex. Now, certain things about this vertex we want to know. So the first thing, let me get a marker here. So y'all, the first thing about a vertex, if you drew a vertical line through that vertex, it will split that parabola in half. So this little line right here that splits the parabola in half, we call that the line of symmetry. Now, for the parabola I drew, the line of symmetry is equal to the x coordinate of the vertex. So for this one, our line of symmetry would be an imaginary vertical line at x equals 1. Okay, so that's going to split my parabola in half. Also, the y value of that vertex, so the y value of the vertex gives us the minimum or maximum amount. So it gives the minimum or maximum value. So it's going to be a minimum if it looks like a valley there, and it'll be a maximum if it looks like a mountaintop or a peak. Okay, so for my parabola right here, since it's a valley, it would have a minimum value of -3, because that's the lowest y value on my parabola. Okay, so the x value gives you the line of symmetry that cuts it in half. The y value gives us the minimum or maximum point. Alrighty, so we got a formula we can use for these. So if given f of x equals ax squared plus bx plus c. So remember, this ax squared plus bx plus c is quadratic equation, just like when we was using our quadratic formula. So given this function, the vertex is given by now remember, since my vertex looks like an ordered pair, the formula is going to come in the form of a ordered pair. So to get your x value for the vertex, you take the formula negative b divided by 2a. So I take my b, make it negative, or change its sign basically is what that negative is doing, and divide by 2 times a. To get the y value of the vertex, we find the function value of that negative b over 2a. So basically, if this was my function, when I found what negative b over 2a gave me, I would plug it back into the x's and get my y value. Okay. And I'll show you when we're working these, how to tell if you got a minimum or maximum. Can you also remember x value, line of symmetry, y value, min or max. So we're going to work an example here. So I'll do a few examples showing y'all this vertex formula, and then we'll do sort of like a word problem at the end here. So my first one, they want us to, let's see, find the vertex, find the axis of symmetry, and the axis of symmetry is the same thing as a line of symmetry. Determine if a minimum or maximum and then find that value and then the last thing, they want us to graph it. So y'all, I'm going to pull this camera down a little bit so we can get these notes. All righty, so our function is going to be f of x equals x squared minus 14x plus 40. All righty, so the first thing we want to do is find our vertex. So remember, the vertex is this ordered pair that I'm going to get by figuring out what negative b over 2a equals. And then once I figure out what negative b over 2a equals, I'm going to put that into this function and get my y value. So negative b over 2a. So for our equation here, there's no number in front of x squared, so that's a 1. B will be negative 14, and then C will equal 40. So A, B, and C are exactly the same as when we did the quadratic formula, okay? It's the numbers in front of each of the variables. So write that negative down. Then I'm going to put parentheses to put my B in. B was negative 14. And y'all remember the quadratic formula had a negative b just like that. The negative in this formula, its only purpose in life is to change the sign of whatever our b is. So if your b is negative, that negative is going to make it positive. If your b is positive, that negative would make it negative. Now on the bottom, we got 2 times a. Well, our a is 1, so that'll be 2 times 1. All right, y'all, so let's see what we get. Negative times negative 14 is a positive 14. 2 times 1 is 2. And 14 divided by 2 will give me 7. So I now know the x-coordinate of my vertex is going to be 7. Which means the line of symmetry is going to be x equals 7. Because remember up here we said the line of symmetry is equal to the x value. So that question is pretty much done. Now, let's get the y value. So the y value says find f of negative b over 2a. Well, our negative b over 2a was 7. So we're going to figure out what is f of 7 of this function. So where they got the x's up here, we're going to put a 7 in. So we got 7 squared minus 14 times 7 plus 40. So a little more order of operations here. 7 squared is 49. Minus 14 times 7 is 98. And then that'll be plus 40. All right, y'all, so let's get that y value. 49 minus 98 is a negative 49. Negative 49 plus 40 would give me a negative 9. So we now know the y value of the vertex. And remember, the y value is equal to the minimum or maximum amount. So we'll figure that out in just a second. But first, our vertex, my x-coordinate was 7 that I got right here. My y-coordinate is a negative 9. Now remember, in MATLAB, you gotta put that vertex point in parentheses. So then they said, well, that's the vertex. So then it says find the axis of symmetry. Well, we know our x value was 7. So the axis of symmetry would be x equals 7. In MATLAB, you have to put the x. It's got to look like a little equation. Now, is it a minimum or maximum? So here's the trick to find that. If your a right here, remember my a was 1. If your a is positive, so if a is positive, if the a is positive, then you're going to have a minimum. If our a is negative, then we will have a maximum. Because remember, if your a is positive, your x squared term, if it's positive, your parabola is going to look like a u. If your a is negative, your parabola is going to flip upside down. Remember, we did that in 7.2. If you put a negative in front of your x squared, it flips that, okay? So my a is a positive 1. And we said if it was positive, you have a minimum. So we have a minimum on this one, like a little valley. And the minimum or maximum amount was equal to the y value. So the minimum amount would be the negative 9. So we had a minimum, and then that amount was negative 9. Now, they want me to graph this, so I'm going to have to move to another sheet to graph it for you. And I'm going to move this back up. So for the graph of that, Now, the easiest thing if you got the TI calculator is just to go in that and graph it in the calculator. So let me see, what was my, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to go out about 10 because I had some numbers that were pretty high on this. So -5 down to -10, and same thing here. All righty, so in MATLAB, definitely the first point you got to plot is the vertex. So plot the vertex first. My vertex was 7, -9. So I would go right over here to 7 and then down to that -9. So that's my vertex. That is 7, -9. Plot that point first in MATLAB, okay? If you don't plot that point first, it sort of messes up what your parabola looks like and it'll count it wrong. Now, we need 2 more points to plot this, okay? So you gotta find me 2 more points. So doing that, you could do any method. You could use the quad and it might give you numbers. Plot them on a calculator to get 2 more numbers. Throw any kind of values into that and get you 2 more values. Now, I'll tell you the truth, on a lot of these, I just set it equal to 0 and get me 2 more x-intercepts and plot those. So I need 2 more points. So I'm going to take that function they gave us, x squared minus 14x plus 40, and I'm going to set that equal to 0. And I'm going to factor this so that I can get my x-intercepts. So x squared, we got an x in front of both of these. So what we need, if we're going to be able to factor this, we need factors of 40. That'll add and give us a -14 in the middle of this. So remember, that's a positive 40 at the end. So your factors could be 1 and 40, 2 and 20, 4 and 10, 5 and 8. Also remember, -1 times -40, -2 times -20, -4 times -10, and -5 times -8. 2 negatives will make a positive 40. So we need 1 set of these factors that'll add to give us a -14. And y'all, that would be your -4 and -10 down here. So you would put them in as your factors, -4, -10. These 2 numbers add to get to -14. These 2 numbers multiply to get a positive 40. All right, so to finish that, I'm going to set both these equal to 0. So the first one, I'll add 4. And I get x-intercept equals a positive 4. Second one, I'll add 10. And get x is a positive 10. So since these are the solutions to this function, these are also equal to the x-intercepts. So I know my graph is crossing here at 4 and over here at 10. So plot your vertex and then plot any 2 points you want to. I just, like I said, found what my x-intercepts were. So that means my graph would come up to the x-axis at the endpoints right there. Okay. Y'all know the way, like I said, you could go on your calculator here. Go to y equals. Let me clear that. Put in, we had what? X squared minus 14x plus 40. I want you to see the graph that it looks like what we got here. Hard to tell, but my graph is going right through there just like we graphed it. Also, if you wanted points, you could hit second graph and you could go through here and get any points you want to the graph. So here's our points I had. Let me go up a little bit here. So see, I had that x-intercept at 4, 0. My other one was down here at 10, 0. But yeah, any 2 points. Usually I get one on each side of that vertex and then let it graph it, okay? All right, y'all, questions on this yet? All right, so we're just going to play with this and find a few vertexes, and then I'll show y'all that word problem. So now I'm finding everything I just found: my vertex, line of symmetry, min or max, that value, and then graph. So this one has f of x equals 2x squared plus 10x plus 15. So the first thing we're going to do is figure out A, B, and C. So y'all, A is 2, B is 10, and C is 15. All right, y'all, so remember my vertex, I got to figure out the x coordinate by finding negative b over 2a. So negative b, which is 10, divided by 2 times a, which is 2. So let's see, that gives me a negative 10 over 4. So we want to reduce this. So 10 and 4 both have a 2 in them. So dividing the 2's out, you get a negative 5 over 2. So we do know now that our x coordinate is going to be a negative 5 halves. So to get that y value, we're going to find f of a negative 5 halves. So that means where we got these x's, we're going to put negative 5 halves. So we got 2 times negative 5 halves squared plus 10 times a negative 5 halves plus 15. All right, so order of operations, I'm going to square negative 5 halves first. So bring down this 2. When you square a fraction, you square the top and you square the bottom. And remember, I'm squaring a negative number, so it's going to become positive. So negative 5 on top times negative 5 is 25. 2 times 2 on the bottom is 4. Now here, you're just multiplying 10 times negative 5 halves. So I'm going to save that for my next step, because this first one's going to have to be multiplied also. And then at the end, bring down my 15. So I'm going to multiply this, and I'm going to multiply this. And I'm just going to put a 1 under those 2 numbers there. Because when you multiply, top times top, bottom times bottom. So y'all, let's see what we get. 2 times 25 is 50. 1 times 4 is 4. Here I got a 10 times a negative 5. So that's going to make that negative. And then that'll be 50. 1 times 2 gives me a 2 on the bottom. And then it's plus my 15. So y'all, at this point, since we're now adding and subtracting, treat the 15 like it's got a 1 on the bottom. because in order to add these, I need a least common denominator. The least common denominator between a 4, a 2, and a 1 would be the 4. So your least common denominator has to at least be the largest number, okay? So since we're saying 4 is the least common denominator, we got to turn all these fractions so that they have a 4 on the bottom. So 50 divided by 4, it's already got a 4, so we'll bring that down. The 50 divided by 2, to make that a 4 on the bottom, you're going to multiply the bottom by 2. If you multiply the bottom by 2, you got to multiply the top by 2. So doing that makes that minus 100 over 4. Now the last fraction will be plus. To turn a 1 into a 4, we got to multiply it by 4, which means we need to multiply the top by 4. So that one would give me 60 divided by 4. So y'all, now we're just going to add these, see what we get for our y value. Now remember, since they all got a 4 on the bottom, my answer will have a 4 on the bottom for this first step. So 50 minus 100 is negative 50. Negative 50 plus 60 gives you a positive 10. And y'all, guess what? 10 over 4 will reduce. Both of them will divide by 2 so that I get a positive 5/2. So my x value was a negative 5/2. My y value was a positive 5/2. Now, when you graph this in MATLAB, they will have the x-axis broken into halves instead of 1. So you'll just go left on the x-axis, -5, and then you'll be over -5/2, and then up 5/2 for that y value. So they will break it down for you, okay? All righty, line of symmetry. Is equal to the x coordinate. So your line of symmetry will be x equals a -5/2. Then we had to know, was this a min or max? Well, my a up here was a positive 2. And we said when the a was positive, we had a minimum. So this one will be a minimum. And the minimum value is the y value, which is 5/2. Okay. Now let me show you how you would graph this. So on MATLAB, it'll have a click for a half, and then your 1, click 2, click 3, click 4, click 5. So that would be 1, 2, 3, 4, 5. Since our points come up with halves, they would give this thing broken into halves, okay? Same thing this way. And then going left, it would be halves going out to the negative side. And then down. Okay, so they're breaking into halves for you. Now, what's nice when it's broken into halves, so my vertex was what? -5 halves, +5 halves. When your scale is broken into halves, all you got to do is go -5 to the left, but go these little clicks. So watch this. -1 half, -2 halves, -3 halves, -4 halves, -5 halves. So -5 halves will be in between -2 and -3 for the x value. Then we got to go up 1 half, 2 halves, 3 halves, 4 halves, 5 halves. So when your scale is broken into halves, you can move left -5, counting hash marks, and then go up +5. Okay. So that should be about a -2.5 and then a +2.5 in that direction. Now, this one, remember, that was our minimum. So that means this graph ain't going to cross the x-axis. So really, y'all, the easiest thing to do on that, we all got calculators. I would go to my y equals and punch in that equation, which was 2x squared plus 10x plus 15. Go to your graph. So it's hard to tell because my scale's so big. Let me zoom this standard. All right, now you can see it a little better. But see, it's on the left side. It's not crossing the x-axis. So setting it equal to 0 ain't working on this one. So I would just go to second graph and get my table. And I'm going to get down here where some of these numbers are sort of small. So look here, I can go to -3, 3, and I can go to -2, 3. So I'm going to use them 2 points. So I'm going to go over here to -3 and up 3. So it's just a little bit higher. I had -2 and 3. Once I plot them 2 points, it'll draw my little curvy parabola, okay? So yeah, it's the easiest way. The other way, you would just have to start putting numbers into the equation. Like set you a little x and y table. And since you were in between -2 and 3, that's probably the 2 points I would have picked to be my x's. Okay. All righty, next example. Now remember, MATLAB, do the vertex first and then do 2 points, one on each side. It'll draw that whole parabola. Right, this one, same thing. We got f of x equals -x squared minus 4x plus 2. So y'all, I'll probably just find everything but the graphing part, okay? Remember, on graphing, I would just plot on the calculator, find 2 points to go with your vertex, and be done. All righty. A for this one is -1. B is -4. And C is a +2. All right, so I'm going to get the vertex first. So the x value is -b over 2a. So that's going to be a -4 divided by 2 times -1. So remember, my a is negative this time. So since a is negative, that means I'm going to have a maximum amount, okay? Well, y'all watch this. Negative makes that a +4. 2 times -1 makes that a -2. 4 divided by -2 gives us a x value of -2, which is also equal to my line of symmetry. Now to get the y value, we're going to find f of that -2. So be careful here, you're going to have a lot of negatives. This negative is in the function, so bring it down. Then use parentheses and put your x in, which is a -2 squared minus 4 times the negative 2. And at the end is a plus 2. So negative, then I put in my x, which was negative 2, minus 4 times my x, which was negative 2, plus that 2. All right, so the exponent goes first. This first negative comes down. You cannot multiply that negative times that negative until we do the exponent. So I bring that negative down. And this says negative 2 squared. Well, negative 2 squared is a 4. So this is going to make this a negative 4 out of this whole expression. Now, this minus 4 times that negative 2 is going to make that a positive 8. And then at the end is a plus 2. So y'all adding all that together, negative 4 plus 8 is 4. 4 plus 2 is 6. So we now know our vertex was the x value of negative 2, a y value of a positive 6. All right, well, we know the axis of symmetry is going to be x equals something. So since that's my x coordinate, x equals negative 2. Then we had to figure out, did we have a minimum or maximum? Remember, we said our a was negative, so that means we had a maximum. And the maximum amount is the y value, which was 6. All right, y'all. So next, I'm going to hit us with a few true false. See, this sort of checks if y'all were paying attention along the way through this chapter 7. So true or false. The function f of x equals 6x squared plus 6x plus 1 has a maximum value. So they're giving us this function. So to determine if it's got a maximum or minimum value, we have to look at our a. Our a is 6. That is positive. So remember, we said, hey, if the a was positive, then this should be a minimum. So this should be a minimum. But they said it was a maximum. So since they said it was a maximum instead of a minimum, this would definitely be false. Okay, so they're going to sort of hit you with some of these questions going off of these notes here. All right, next true false coming up. I'm going to push back up. All right, y'all, true or false? The graph h of x equals x plus 2 squared can be obtained by translating the graph of h of x equals x squared, right, 2 units. So this was from the information in 7.2 when we was translating these graphs left and right. Remember, when I pack the x's inside the parentheses, that +2 is either going to move me left or right. So we learned that when you added 2 to the x, it actually moved it left. If I would have subtracted 2 from the x, it would have moved me right. So since the 2 is being added, this should move left. But y'all, they said right. So since we know this should move left, that one would be false. All right, true or false? The axis of symmetry of the function f of x equals -9 times x plus 8 squared plus 4 is x equals -8. So let's see. If we had a graph of a parabola, remember the basic graph is like this. So that would be your basic graph. Remember, if we added 8, remember we said right here, if we added it should move left. So this would move left over here to -8 and make the parabola. So if it moved your whole parabola over here to -8, then your line of symmetry would be cutting right through that -8, which is what they said. So this one would actually be true. Okay, now had they said x equals +8, that would have been false because remember, +8 would have moved it right. All right, so now we got a good question coming up for y'all. Well, not a question, but a sort of lengthy example here. So let me get my papers turned over here. Starting to curl up. All right, y'all, so a lot of information on this next example. They want us to find the vertex, determine minimum or maximum value, and give that value, find the range, find intervals of increasing and decreasing, and then let's see, and we don't even have to graph this, and they just want us to find all this information. Our function is going to be f of x equals x squared minus 10x plus 24. So since they want this increasing and decreasing, I'll probably graph it by hand on here. That way you'll see what we're talking about on these, okay? So the first thing is our vertex. So the vertex, x coordinate, -b/2a. So let's see, a is 1, b is -10, and C is 24. So we got negative times negative 10 divided by 2 times A, which is 1. So that's going to give me a positive 10 divided by 2. And 10 divided by 2 gives me an X value of 5. Now I want the Y value, which will be F of 5. So that'll be 5 squared minus 10 times 5 plus 24. So let's see, 5 squared would be 25. Minus 10 times 5 is 50. Plus your 24. All right, so let's see what that gives us. 25 minus 50 is a negative 25. Negative 25 plus 24 is a negative 1. So we know our vertex is 5, negative 1. All right, min or max value. Well, A is positive. So since A is positive, it's going to look like a U. So this will have a minimum value. And the minimum value is equal to the Y value, which is a negative 1. So notice this one didn't ask me for the line of symmetry, so I'm not going to have the X equals on this one. Now they want the range. So what I'm going to do is sort of graph this for the last part of this. Okay, so let's go over here and graph this. So it's over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, negative 5, 6, 7, 8, 9, 10. All right, so we do know our vertex is at 5, negative 1. So I'm going to go over here to 5 and down here to negative 1, which is about where I put my number. We said it was a minimum value. So that means, now we don't care about graphing this one technically. So I just needed this point here. And I know this graph curves up because that was a minimum. Okay. Because the range and intervals can be found off of this. So remember, the range is the Y values. And the Y values start right here on this graph. And they go up forever. So for my range, now remember, range on the number part will always have square brackets. So the minimum Y value was that negative 1, right? Because we found that using our vertex. We knew that that Y value was negative 1. So the range is going to involve that Y value. So it goes from that negative 1. And since my parabola curves upward, my range is headed towards what we call positive infinity. And infinity always has curvy parentheses. Okay. The number part of it will have the bracket. Infinity will have a parenthesis. Now, y'all, if this was flipped over, now this example wasn't like that, but I just want to show you something. If your parabola was flipped over, your range would come from down here and go to your maximum number. So if you was flipped over, your range would start down here at negative infinity and then go to whatever your number was and have a bracket. Okay. So range is backwards when it's flipped over. All right. So now we're going to find the intervals of increasing and decreasing. So this will be increasing and that'll be decreasing. So intervals of increasing and decreasing go from left to right, and they're going to be on the x's, okay? So you see how this side of this parabola is coming in and going down? This side is decreasing. When it's going uphill, it's increasing. So we want to know what x values is this. Let's see, we're increasing first. So what x values is my graph increasing? Now, increasing and decreasing, always use parentheses, because this point can't be both increasing and decreasing, and that's why we use parentheses, okay? So it starts increasing at the value of 5 on the x-axis. And remember, that's the x-coordinate of my vertex. So it's also the point where it goes from increasing and decreasing to the other. So at x value of 5, as I go right out my x's, my graph is increasing. So it's increasing from 5 to positive infinity. Then it says, hey, where's your graph decreasing? Well, this left side coming in is decreasing. So since it's coming in from the left side decreasing, we say it's coming in from negative infinity. Because remember, this graph goes on forever. Remember, we're looking at the x's. So as I come in the left side from negative infinity, my graph is steadily decreasing until I get to this x value. Well, that's the vertex again, and that x value was 5. So increasing and decreasing, we'll either have a number in some type of infinity or the infinity and then the number, okay? All right, y'all, then let's see. Oh, that was it for that one, okay? So if this was a negative x squared, my parabola would have been flipped over. And this one would have been increasing from negative infinity to the x value, and then decreasing from the x value to positive. So you just got to see which way is your parabola pointing, okay? All right, y'all, so I just got one more to keep you on today. So this is going to be a word problem. It sort of shows you why we can use these vertex formulas in the real world. So this one talks about a toy rocket. So a toy rocket is shot vertically into the air from a launching pad seven feet above the ground. Initial velocity of 96 feet per second. So then they're saying the height in feet above the ground at t seconds is given by h of t equals negative 16 t squared plus 96 t plus 7. So they're using this equation. If you know the time, then you can find the height that that rocket's at. So remember, since that's a negative t, negative a there, that means this parabola, if you was to graph it, would look like a upside down parabola. So what they want to know on this question, what's the maximum height of the rocket? And then how many seconds does it reach maximum height? So this one, since they're asking how many seconds to reach the maximum height, that's going to equal to t. Because t is time and that deals with the seconds. Then it says, what's the max height of the rocket? Well, that's going to equal my h of t. Because that's what the formula is for, right? The height. So in the questions, the first thing they want to know, how many seconds to reach maximum height? So how many seconds to reach maximum height? That's going to be the x value of the vertex. Then when we actually find the maximum height, this maximum height here is going to equal the y value of the vertex, okay? So first we're going to find how many seconds, and then we'll find that height. So we're looking for our t coordinate of the vertex. Remember, we're not using x's here, we're using t. So the t is going to equal negative b over 2a. So look, a is negative 16. Remember, since that was negative, that's why I knew this would be upside down. And it makes sense. If your rocket starts on the ground, as time goes up, it's going to get higher and higher and higher. And then at a certain point in time, your rocket's going to reach its maximum height. And then as time goes on, the rocket's going to come down. So let's see how long it took it for that rocket to get to that height. So B is 96, and C for us will be the 7. So we got negative 96 over 2 times A, which was a negative 16. Now, y'all, I'll tell you where they got this formula from. Remember up here, they said it was 7 feet above the ground. Well, that's 7 feet. And if time was 0 at that point, all this would be a 0, so you'd be at 7, which would be true. 96 feet per second velocity, that's how they got this 96 times t. So your speed is your velocity. So ever how many seconds you're going, multiply by your speed. The negative 16t squared part of this is gravity. That's why it's negative, because remember, gravity wants to pull you down. All right, so enough about that. How about this? Negative 96 over negative 32. So 2 negatives make that a positive. 96 divided by 32 is 3. So it took my rocket 3 seconds to reach maximum height. So 3 seconds to reach maximum height. Now, to find that maximum height, I'm going to find h of 3. So I'll put my 3 seconds in for the time, and that'll tell me how high my rocket went. So I got negative 16 times 3 squared plus 96 times 3 plus 7. So exponent first, 3 times 3 is 9. And then I'm just bringing everything else down. All righty, y'all, so let's see what I get. Negative 16 times 9 is what? A negative 144. 96 times 3 is 288. And then plus my 7. All right, negative 144 and 288 is a positive 144. 144 plus 7 gives us a maximum height of 151. So it took 3 seconds to reach a maximum height of 151 feet. Hey, y'all, so that's sort of things that you can do with this vertex formula is find things like maximum height. If I wanted to build a pin or something, I could use it to find maximum area. So any quadratic equation, you can find maximum and minimum values. All righty, y'all. So do I got a question? Any questions? All right, so I'm going to stop our recording and I'll send this out so you have this video later. And I'll see y'all next Tuesday in class. So y'all have a good weekend.
You too.